All right, these are the answers to page 79. And the first one asked us to look at this graph and come up with the right-hand, left-hand limit, and then talk about the full limit. So from the right side, this function looks like it's approaching a value of 0. Does not matter where the dot is. That's where the function value is, but we're talking about the limit. So from the right side, we're heading on to a value of 0. From the left side, same thing. We're heading to a value of 0. So our left-sided limit is 0. So right side and left side both agree. They're both heading to the same point. So therefore, we would say that the limit is 0. For number 6, from the right side, I'm coming at a value of 0. But from the left side, I'm approaching this value of 2. Okay? So right side limit is 0, left side limit is 2. They do not agree. We have a gap or a break or a jump discontinuity. And so we would say the full limit does not exist. Right. For number 12, we're asking what's going on as we approach 2 from the right side. So if we had a graph of this, or if we just maybe plot some points, if I put 3 in, I'm going to get 1 over 1. So I get 1. If I put 4 in, I get 1. If I put 5 in, I get 1. Anything to the right of 2 is going to give me 1. Okay? If I go anything less than that, if I put, say, 1 or 0 or negative something, I'm going to get negative 1. And this is a real popular kind of graph with the AP test. I'm not exactly sure why they're in love with this, but we see it a lot on the AP test. And so anytime you see absolute value divided by itself, kind of like this, you should expect this kind of graph. And coming from the right side, we're approaching a value of 1. For number 18, we're told that the function is 1 minus x for everything except, everything greater than 1, and it's x for anything less than or equal to 1. If we're coming at 1 from the right side, we're coming from numbers that are greater than 1. So this is the one that we should be trying here. So if I put 1 in there, 1 minus 1 is 0. That's what it looks like it's heading to as you approach that. For number 26, we're asked to discuss the continuity. So I can see right away that we're going to have a problem at x equal negative 1. That's what makes the denominator 0. And since the top can factor into x plus 1, x minus 1, and those x plus 1s can cancel, and since that's the case, I know that that's just a hole, or what we call a removable discontinuity. Okay. So if you're saying, well, which one is it, whole or removable? They're the same idea in here, okay? The whole is what it'll look like. We call it a removable discontinuity. As far as 35 goes, when I look at this, 3x, really there is no issue. I can multiply any number by 3. There's no reason why I can't. I can take the cosine of any number. This does not give me any reason to be concerned right here. So there are no discontinuities for this problem here. For 37, however, we're going to have a different issue. If I pull that x out, I'm going to have x minus 1 left over. So we have a problem at x equals 0 and at x equal 1. Okay, those are the two numbers that would make this denominator 0. Okay, so what's the problem at 0? Well, that's not as big of a deal because the x actually does cancel top and bottom, and because of that canceling, this is just going to be a hole in the graph, or like we said, a removable discontinuity. Okay. The x minus 1, however, didn't go away. It stays. It's a little more of a disruption. That's going to be a vertical asymptote, or what we call a non-removable discontinuity. Okay, so factor it out, see what makes the denominator 0. Those are your discontinuities, those are your problems, and then you kind of see which kind they are from there. Okay, for number 48, we have negative 2x for anything less than or equal to 2, x squared minus 4x plus 1 for anything greater than 2. So anything less than 2 is going to have no problem. I can take negative 2 times anything. Anything greater than 2 is not going to have a problem. The only problem I might have is at this transition, right? If there's a gap or a break in the graph right there, then that will be a discontinuity. So how do I know if that's an issue? Well, let's go ahead and put 2 into here. And at x equal 2, so at x equal 2, this top part becomes negative 4. And then at x equal 2 for the bottom, I get 4 minus 8 plus 1, which is negative 3. So if you were looking at a graph of this, at negative 2, at that transition point, we would have a break, a little gap. So our discontinuity is at x equal 2, and it's a non-removable discontinuity, right? Or what we call a jump discontinuity. Okay, anytime we have one part and then it jumps over to another, that's what we see here. Okay. For 57, it says, what would A have to equal in order for this to be continuous? And so what I want to do is put 2 into the top. Again, at that transition point, the top would equal 8. For the bottom, when I put 2 in there, the bottom would equal 4A. So what would A have to equal? Well, whatever would make 8 equal 4A, and that would be 2. So if A equals 2, then we have no problem. At that transition, they both equal the same thing. We would have a nice continuous function. Anything else is going to create a break, gap, jump discontinuity. All right, last question, 77, says, why must there be a 0 between 0 and pi for this function? So the idea about this is, let's find out what f of 0 equals. Let's find out what f of pi equals. We know this is a continuous function, and let's see if there's a way to kind of bridge or, butt up to that 0 there. So if I put 0 in, I get 0 minus 2 minus cosine 0, which is 1. I get negative 2 minus 1, which is negative 3. Okay. So when x is 0, the function is down at negative 3. If we put pi in, I'm going to get pi squared, which we know is about 9, a little bit more than 9. Okay, minus 2 minus cosine pi. Cosine of pi is negative 1, so minus negative 1 would be plus 1. So really we get something about 9 and then minus 1. So this is going to be about 8 point something. I know this is not the most technical. You could use a calculator if you want, but I'm just thinking without a calculator, I know that's positive 8 point something or other. All right, so the function is at negative 3 when it's 0, and then when it gets to pi, it's in the positive range. So by intermediate value theorem, IVT, f of x has to equal 0 somewhere in the interval 0 to pi. All right. Again, because it's negative on one endpoint, positive on the other, somewhere it had to cross 0 because f of x is a continuous function. Okay, I guess that would be a good thing to say, because f of x is continuous. So by intermediate value theorem, we got our answer. All right, hopefully you felt good about that.